This is part 2 of a series of demos showing how to use HPC-09 v6 in daily production. We quickly run through how the operator enters data for the production line from part 1, but in this case we will also assume that the operator allows use of bed heating. We then focus on what happens when the measurement station is placed on the slab, and HPC-09 performs the corrected prediction. Remember, HPC-09 communicates wirelessly with the measurement station and with a control panel. Blue lights indicates curing status, red lights indicates bed heating status.
We now enter data for bed 2 at the speed a trained operator will use, and then slow down when it's time to place the measurement station on the slab. Serial number for bed 2 is 9902. Since we are allowing bed heat to be used, we must enter what pouring temperature we intend to use. There are now two variables that determine the curing time, pouring temperature, and bed heating. HPC-09 is now performing an initial prediction based on operator and measured input data. This is all the operator has to do. From now on, HPC-09 is remote controlled from the measurement stations. The blue graph shows the initial prediction. The tab shows initial and corrected curing data. Blue columns shows data for the initial prediction, and red columns for the corrected prediction. We see that 1 hour and 45 minutes bed heating is needed with the current input data. It's now 2 hours since we entered data for bed 2, and the casting is starting. The bed operators then turn the switch on the measurement station to position 1. HPC-09 detects this and performs a new initial prediction using the current measured ambient temperature. We are running a simulation, which means time is running 60 times faster than normal. The simulation mode is very useful for demo, test, and educational purposes. Casting has now finished. An operator places the measurement station on top of the slab 5 meters from the end and turns the switch to position 2 and puts on the bed covering. HPC-09 detects this, measures the actual pouring temperature, and performs a corrected prediction based on the new data. The red graph shows the corrected prediction. The pouring temperature is measured to Ts equals 22 and not 23 degrees centigrade, as we indicated initially. Thus, HPC-09 has corrected the bed heating from 1:45 to 3:30 hours. This is how the measured temperature development should look if the measured temperature falls below or above the red graph, or if the shape is different, then we have a discrepancy and a potential problem. This view shows the corrected temperature predictions at the bottom, middle, and right-left edges of the slab, explained in detail in part 1. This is the measured and corrected prediction for the strength development. HPC-09 will also show an extrapolated strength estimation, useful when we have a small discrepancy between corrected predicted and measured temperature. This view shows the corrected strength predictions at the bottom, middle, and right-left edges of the slab, explained in detail in part 1. This view shows current data. 100% means bed heating is turned on. We can see when casting and curing is finished, and the current strength. Measured total casting and curing bed heat and total curing time is also shown. We see that measured temperature, green graph, starts to fall below the corrected prediction, red graph. If this trend continues, we may be facing a discrepancy. We now fast forward to the time when the target strength is almost reached, and a report will be generated. Target strength is reached, and HPC-09 V6 generates a report for the scouring. Time for report generation can be changed in one of the settings views. The measured temperature development falls far below the corrected prediction. We have detected a discrepancy. Let's investigate this problem. Comparing the normal humidity graph from the calibration data with the humidity graph from the scouring, we see that the humidity falls far below the normal values. This may indicate that something is wrong with the bed covering, or there may be too little water in the concrete. Target strength is reached after 7:45 hours, which is 45 minutes after the target curing time. This is due to the detected humidity discrepancy. Let's investigate the generated production statistics and bed reports.
The main page contains 20 columns of information about each production line. This information supports the existing plant quality regime, with additional vital information. The statistics page contains strength standard deviation information for selected mix designs and strength range. This is real plant production data, and we see that standard deviation is very low, 1.55 megapascal for the strength range. The bed heat page contains information regarding bed heat. How much is commanded by HPC-09, and how much is manually commanded by the operators. Savings of up to 75% is easily achieved in Nordic countries. We now look at the detailed report for production line with serial number 9902. The detailed data in the report provides precast engineers with information necessary to decide what's going on with your concrete, whether designing new mixes, or when pinpointing problems. Thank you for watching part 2 in our demo series. We have seen the accurate temperature and strength predictions made possible by our advanced calibration technology and advanced modeling. The demo has given insight into how HPC-09 V6 may help you achieve lean concrete slab manufacturing. The lean aspects are made possible through the system's accurate temperature and strength predictions. Though advanced, the system is very easy to use. See www.objective.no, www.objective.no/lean.